everyone, it's Alyssa and welcome to You Can Learn Math. Today is about the quadratic formula. Now, quadratic formula is something we use when we are trying to find the zeros of a quadratic equation. Okay, if the term finding the zeros doesn't ring any bells, please go to the description below. There's a video on finding the zeros. I go into in depth on this. This is a broad topic that comes up. There's a lot of things that are connected to quadratics. I can't cover them all in one video, so I've split them up. Also, if you're looking into factoring of quadratic equations, I have multiple videos on those. I have factoring when you don't have a number in front of the x, when you have a negative in front of the x, when you have a number bigger than 1 in front of the x as well. All those in the description below. This one is all about the quadratic formula. Quadratic formula is what you use when either A, your teacher tells you to use it, or B, you can't factor it. Now, I'm going to do one that is a straightforward if your teacher told you to use it, and then I'm also going to do one where it would be if you can't factor it. You'll see it both ways. So first off, what is the quadratic formula? The quadratic formula is, it looks kind of monstrous, frankly, but it's based off of this x version, or this representation, if you will, of a quadratic, where A, B, and C are numbers, or your book will probably call them constants. A constant. They are constants. They are numbers. So for example, if I had 3x squared plus 2x plus 5 equals 0, 3 is my A, 2 is my B, and 5 is my C. One thing that is going to be very important for these sort of things is if this is a minus, if there's a minus anywhere in here, then that means your B is -2. That minus or negative sticks with that constant. Very important. Do not forget that. This will come into play. Another thing, when you're using quadratic formula, it has places in the formula for A, B, and C. If you do not have a B or a C, you can still use it. You just put in 0 for those. For example, if this was just 3x squared plus 5 equals 0, then everywhere there's a B in the formula, you would just plug in 0. Frankly, if you don't have a B or a C, there's easier ways to solve this. There just is. If in this particular case, I would be just subtracting 5 and then solving 3x squared equals -5. That's way easier. And if it was something like 3x squared minus 5x, I'd pull out an x and set each of those separately equal to 0. Again, if those two things I just mentioned don't ring any bells, please watch the other videos on factoring. That will be very helpful. Again, though, some cases may occur where you're given something like this that you could much more easily solve a different way, but your teacher's telling you to. In which case, please use the quadratic formula if that's what your teacher's telling you to use for those problems. That's got to trump everything, even if it's not the easier way. So what is the quadratic formula? It is this monster. X equals a -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Square root. Okay. Yikes. I know, but you do have to remember this. This is something you're going to have to memorize. I don't know any handy mnemonics for how to get this in your head. I wish I did, because it took me a long time. I'm not good at memorizing stuff like this. I'm just not. I freely admit it. These random formulas that don't have or don't seem to have any rhyme or reason when you look at them, I'm not good at memorizing them at all, but you gots to do it. So here's an example of one that you could solve with factoring. You absolutely could. This would be the kind of thing where if it was on a test, you'd go by what your teacher told you to do. He or she may say, use quadratic formula for this, or they could say, use whatever you want. That both of those happen. In this particular case, if it was a use whatever you want, you could use factoring or quadratic formula. So let's use the quadratic formula. Just to show you, really show you how everything fits in, I'm going to rewrite it. And then I'm going to replace everything step by step. Okay, so first off, negative b. I want to put my b in, and this is what I said. Really pay attention to the sign. Up here, my b is negative 5. That's my b, negative 5. So I put negative 5 in for b. This little negative out here, I don't just go, oh, negative b. Well, b is negative 5, so I plug in negative 5 for that. Nope, nope, nope. Your b is negative 5. This negative here is part of the formula. So I plug negative 5 in for b inside those parentheses. Makes a difference, a huge one. Inside the square root, let me erase, don't being persnickety. Okay, so b is negative 5 squared. And then we have 4 times a times c. 4 is part of the formula, times a, my a is 2, times c, my c is 3. On the bottom, 2 times a, again, a is 2. Yeah, I write my 2's differently at different times. Why? I don't know. Do I have to have a reason? Okay, negative 5 is a positive 5. Plus or minus the square root of negative 5 squared is 25. 4 times 2 times 3. 4 times 2 is 8. 8 times 3 is 24. All over 2 times 2, which is 4. Okay, I'm going to slide this over a little bit. All right, let's simplify it. X equals 5 plus or minus. 25 minus 24 is 1. The square root of 1 is 1 all over 4. You go, oh, hey, that looks pretty simple. Am I done? Not so fast. No, 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 no. This is a plus or minus. There's 2 options. I have to do both of them. So x equals 5 plus 1 over 4, and x equals 5 minus 1 over 4. I have to solve both. So here, 5 plus 1 is 6 over 4, and I can simplify that to 3 over 2. On this side, 5 minus 1 is 4, and that simplifies to 1. So x can equal 3 halves, or it can equal 1. Again, you could have done this by factoring, but that's how you use it. You use the quadratic formula. Which, I mean, even things that can be factored, sometimes it can be hard to see how to factor them, in which case this would be quite handy. Now, in some cases, there's absolutely no way we could possibly factor it. Here's one. 8n squared minus 4n minus 18 equals 0. Handy fact, for something like this, if you have a problem it equals 0 and there's a common factor in all 3 of these numbers, you can pull it out. You can divide it. And that's what I'm going to do, because this can get, these numbers can get quite big, and I want to keep it more simple. 8, 4, and 18 are all divisible, or excuse me, 8, negative 4, and negative 18 are all divisible by 2. So I'm going to divide everything by 2. That gives me 4n squared minus 2n minus 9 equals 0. All right, so it's a little more manageable. The numbers will be a little bit smaller. Now it's time to start plugging it into my formula. Okay, same thing. X equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. What is my b? My b is negative 2. And here, b squared, negative 2 squared. 4 times a times c. 4 times, my a is 4. My c is -9. And on the bottom, 2 times a. My a is, again, 4. All right, now it's time to start tidying this up. I'm going to scoot this over, give us a lot of room here to work with. Okay, x equals -2 is +2. Inside my parentheses, or inside my square root, -2 squared is 4. Minus, I'm going to keep it in the parentheses for a second, 4 times 4 times -9. 4 times 4 times -9 is -144. So 4 minus a -144, all over 2 times 4 is 8. Again, here's another one of those minus, and inside is going to be a negative. Be very careful with your minus negatives and your minus negatives. That is the easiest way to trip up with this, because this really is just a plug and play situation. You plug in the numbers, you do the math, it spits out your answer. Fairly straightforward as long as you get the formula right and as long as you keep track of those negatives. So easy to mess those up. My chair is really squeaky. I hope you don't hear that. Anyway, okay, so I am going to go up here, simplify a little further. 2 plus or minus square root of 4 minus a -144 is the same as plus 144, 148, all over 8. All right, now anytime I have something under a square root sign, I want to look for perfect squares in there. And I have a video on that, on simplifying square roots. So what I'm going to do really quickly, and again, if this doesn't look familiar, please watch the video down below on simplifying square roots. 2 and 74, and that's 2 and 37. 37's prime. Hey, and there's my pair, 2, 2. So 4 comes out. Again, video down below if that doesn't make any sense. All right, so x equals 2 plus or minus, and because the square root of 148, my little factor tree I just saw over here, is same as square root of 4 times 37, then this is 2 square root of 37. So square root of 4 is 2, all over 8. Now, once I've gotten this far, I look for common factors in this, this, and this. Hey, those three numbers. Yes, there is. There is a common factor in there. It is 2. I can pull that out. Here's why. Because on top, I could rewrite it as 2 times 1 plus or minus square root of 37. And then there it is on bottom. 8 is the same as, whoa, what's just happening? Why did it do that? 8 is the same as 2 times 4. So then I can cancel those 2's out. And I am left with, why is it doing this? This is so weird. I'm pressing undo and it's undoing things up above that I did like 5 steps ago. That's very bizarre. And I'm left with 1 plus or minus the square root of 37 all over 4. Now in this particular case, at this point, because we can't simplify square root of 37, and the vast majority of the time, your teacher is going to want you to leave it like this. She or he is not going to want you to plug it into a calculator and see what it is. There may be exceptions to that. Double check with your teacher and see what they want. 9 times out of 10, they either want it left like this, or they may want you to write it side by side, 1 plus square root of 37, 1 minus square root of 37, both of those over 4. Usually it's one of these two. Usually they do not want you to put it in your calculator and get something else. There are occasions when you're going to get a negative under the square root. Those are imaginary roots, imaginary answers. I'm going to be making a video shortly on the quadratic formula and imaginary roots, and also graphing and imaginary roots. So please, that should be up very shortly. Please go to the description below for that video. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.